Hello Year 12 Single Mathematicians. We're just going to continue with Chapter 1 from the Year 2 book, 1.4 Partial Fractions Part 3. Now we've done two previous types. Today's type is a little bit different and we need to be able to split expressions with repeated factors into partial fractions. Now what I mean by repeated factors is something which looks like this. So you've got some numerator over one of the factors in the denominator is squared, so it's been repeated. Now, this is the most difficult one to remember, and it is not intuitive, and that's one of the reasons why it's difficult to remember. But this splits up into not just an x plus a squared and an x plus b, but the repeated factor once, then the repeated factor twice, and then x plus b. So most people think it's just going to be those two, but the repeated factor appears in there once, twice, and then x plus b. And that's how this splits up, so you need to know this type. And an example will look something like this. We have to split 11x squared plus 14x plus 5 over x plus 1 squared 2x plus 1 into partial fractions. So firstly, you recognise the denominator has a repeated factor. X plus 1 is repeated. They only do squared, but this kind of pattern would work for higher powers too. And this would be identical to a over x plus 1, the repeated factor once, plus b over x plus 1 squared, the repeated factor twice, plus c over 2x plus 1. And the next step is very similar to the previous types, where you effectively work on the right hand side and you collect the fractions together with the same common denominator. Now the common denominator is always the same as the denominator on the left hand side, always. If it isn't, then you've done something wrong. So 11x squared plus 14x plus 5 over x plus 1 squared 2x plus 1 is identical to, now this is where you've got to be very careful. The new denominator needs to be exactly the same. X plus 1 squared 2x plus 1. But this numerator already had an x plus 1. So I don't have to just times the numerator by the other two denominators. That will not work. In order to get a denominator of x plus 1 squared 2x plus 1, I'd have to times the first fraction just by x plus 1, 2x plus 1. Not x plus 1 squared, but just x plus 1, 2x plus 1. The second numerator is already over x plus 1 squared. So the only thing I have to times that by is 2x plus 1. Nothing to do with this denominator at all. And then finally, this one's already over already over 2x plus 1. You need it to be over x plus 1 squared 2x plus 1. So you have to times by x plus 1 squared. And that would be the only correct way of doing this. See, both denominators are identical, so you effectively forget about them. And you're left with 11x squared plus 14x plus 5 needs to be identical to a x plus 1, 2x plus 1, plus b, 2x plus 1, plus c, x plus 1 squared. And very similar to the previous types, you make use of the identity symbol, and the identity symbol means it works for every single value of x. And you've got three unknowns, a, b and c, so you're expecting three equations. And if you are clever and you pick specific values of x, those equations become really straightforward. Now a good value of x to pick would be x is -1. And you show the substitution. Now that bracket in this first term goes to 0, so this entire term goes to 0. The third term, that bracket goes to 0, so that entire term goes to 0. So you're just left with the second term, which would be b brackets 2 times -1 plus 1. The left hand side simplifies to 11 subtract 14 plus 5 is 2. 2 times -1 is -2 plus 1 is so that's -b. To give you b is -2. Okay, another sensible x value to pick would be x is -1/2. 11 -1/2 squareds plus 14 -1/2 plus 5 needs to be equal to, that bracket goes to 0, so the first term disappears. The second term, that bracket goes to 0, so the second term disappears, and you are only left with the third term, like so. Okay, let's see what this simplifies to. Where's my calculator? 11 -1/2 squareds plus 14 -1/2 plus 5 is 3/4. The other side is equal to 1/4 c, which gives you c is equal to 3. So c is equal to 3 for the second one. Now, because you have a repeated factor, there are only two good or sensible x values to pick. There's not like a third bracket to pick. So, but we're left with one more unknown to work out, which is the letter a. But then you could just pick any other x value, which is not -1/2 or -1, and you'll find that third unknown. And the value I tend to pick, if it hasn't been picked already, is 0. If 0 had been picked, I'd pick 1. If 1 had been picked, I'd pick 2. If 2 had been picked, I'd pick 3, and so on. So I'm going to pick x is equal to 0, just because I need to pick another x value. The reason that I choose that is because these two terms obviously disappear. It's easier to do the maths. Then you get a 0 plus 1, 0 plus 1, plus b 0 plus 1, plus c 0 plus 1 squared. And if you simplify all of that, that's just a or 1a, that's just b or 1b, that's just c or 1c. And because you know the values of b and c, you can substitute them in. -2 plus 3 is 1. Take it to the other side, it would give you a is 4. And that would be the values of a, b and c. Now, in order to get the final mark in an exam, you have to write the entire thing. So I'm going to call that original partial fraction expression there, f of x, and then state f of x is equal to 4 over x plus 1 plus, subtract 2 over x plus 1 squared plus 3 over 2x plus 1. And that would be my final answer. And that's pretty much it. So the questions I would like you to complete are on page 13. It's called exercise 1E. I would like you to try the odds and the odds only.